I can see here that it's like a quadratic function. This part here, right? So I can type maybe, we can start with the most basic quadratic function. We have f of x equals x squared, for example. Okay, that's the most basic function that I can type. Now, I want to move this function to the left by how many units? As you can see, the vertex here, we can put the vertex at -2. So meaning I have to move this function to the left by 2 units. What will I do with the x squared? Am I going to add to the input, subtract from the input, add to the output, or subtract from the output? Please type your answer or raise your hand. Okay, sabi ni Carmen, x plus 2. Yeah, so if you add to the input by 2, it will move the graph by 2 units to the left, no? Kasi if you add here plus 2, it will move up, right? So you have to add to the input. So meaning I can retype this to x minus or x plus 2 quantity squared. Okay, so one problem solved. Okay, then I want this to be a bit lower. This is a steeper graph than I want it to be. So what do I do? I want to lower this part here. Is it vertical stretching or horizontal stretching? It's vertical stretching, right? So in vertical stretching, you are multiplying the output, like the entire function, by a number. But this time I want to lower the value of y, meaning I have to multiply a number that is less than 1. If you add a negative number, we add a negative number, so meaning minus 1, for example, it will go down, right? Because adding to the output and the subtracting from the output is actually um, um, vertical translation. But I want this only the y. I will not, I don't want to move this, no? Okay, 1/2. We multiply by 1/2, maybe. So let's try zero point 0.5 maybe. Or 1/2. Of course, you can type 1/2. Okay, so almost. Very good. But I want it to be a little lower. So as you can see here, this is a little lower. 0.45 sabi ni Carmen. 0.4. That's sabi ni Gwyneth. Gwyneth or Gwyneth? Right? In any case, maybe 0.4 or 0.5. 0.4. Sobrahan naman. So remember that zero point 0.4 is 0.40 and 0.5 is 0.50. So maybe we can have something in between. 0.45. Okay. So almost. We have a little space here, but I think it's okay. We can just make the graph a little bit thicker. So this is a bit of cheating. Not really cheating, but okay. Because I think the estimate is quite good. Of course, you can be as accurate as you want, if you want. As accurate, yeah. As accurate as possible if you want. And then we can, now that we are done, we have to cut the graph. So it's from here up to maybe up to here. Not really two because we still have some space here and we want to use this. Right? Right, very good. Sabi ni, is it Jedidia? Try the middle point of zero point 0.4 and 0.5. Very good. Very good, everyone. So this is between -4 and -5, but it's a little bit closer to -5. So maybe -4.7, maybe 4.8. So let's try. So this is a little bit of guess and check, but the guessing and the checking is actually very mathematical. You can just guess and check, wildly. So this is maybe -4.8. Let's see 4.8. So we can do it 4.8, or maybe a little bit shorter, 4.7, -4.7. So one thing that you will notice if you click on the equation is it becomes an if statement. So this is a GeoGebra command, so we cannot really do something about it. But I think it's easy to determine which is the equation and which is the interval. So here we have to put -4.7, and maybe somewhere here maybe -1.8. So let's see. So x is less than or equal to -1.8. Okay, I think we are okay with -1.8. Or if you want to make it a little, let's try -1.7. So again, this is only then the details of it. So -1.7 is still okay. Okay, so it's an estimation, but yeah, very good, Maria Catherine. Okay. Okay, so do you think we can use this equation for the other side here? We can pattern from this equation. Anyone? What do you think should be the equation of the other? We can start again from x squared. So g of x equals x squared. Just to review what we have learned, we want to move to the right by how many units? By 2 units. So this time, is it +2 or -2? Okay, so sabi ni Esther, 0.45, no? So that's 3. Let's see yung sinabi ni, sabi din ni Yuna. So let's try 0.45 x minus 2. Medyo related sila, no? They are related because they are like almost symmetric, no? So what is the domain of our function? Of course, we have to change also the thickness, same as the thickness of this one. What's the thickness of green? It's 8. So we can also change this to 8. What do you think is our domain here? This one is from -4.7 to 7. What do you think is our domain? Okay. So mayroong 1.7 to 4.55. So very accurate. So let's try 1.7, comma, x is greater than or equal to 1.7. From here, this is -1.7. So maybe we can try 1.7. Pwede kayang 4.7 then. Let's try 4.7, for example. So less than or equal to 4.7. No, it's not possible, right? Okay. Sybil, 4.5. Yeah, it's a bit shorter, so maybe 4.5. And it's a little bit shorter. So let's try 4.6, for example. 4.6. And again, it's a little bit protruding here. So 4.55 is correct. I think someone said 4.55. So I think, yeah, 4.55, sabi ni Carmen. Great. Okay, so I think you're getting the idea. Another example is we don't have to finish everything, but I think you're getting the idea. Um, for example, this one, I want this to be cosine x. You remember the graph of cosine x, right? So for example, h of x, you can have many different functions if you want. So, and of course, one curve can be, you can use many possible functions. For example, you can also use quadratic function here if you haven't learned sine x yet, a trigonometric function. So for grade 8, you can also use quadratic functions here that opens downward. No, but here we use just sine function, cosine function. So we have another function, and I want the cosine function. I want the height to be a bit lower. What should I do? This is still vertical translation. So when you're no vertical scaling. So when you are talking about the height without changing the position of the function, you are talking about vertical scaling. So as you can see, this is almost half. The height here is almost half the height of this point here. So maybe I can multiply by zero point 0.5, one half. It's easier to work with decimals here because, of course, fraction is a bit confusing if you're talking about two digits. Okay, so almost. Maybe we move it up a little bit. It doesn't fit. Maybe 0.2. No, 0.1. Almost. Okay, but we need to change the height a little bit again. So maybe 0.45 again. A little bit more. 0.4. A little bit more. 35 maybe. Okay, so it's not really, it's quite difficult. But I guess this is a good estimate. And again, if you have time, of course, you can be as accurate as possible. And what is the domain of this? What is the domain of this? Yeah, from negative 1.7 to 1.7. Because here we ended at negative 1.7 and then we started here at 1.7. So maybe we can use that domain. So x, this is a rough estimate. Of course, again, you can be as accurate as you want if you have time, but we don't have a lot of time. Okay. And then we can make this 8. Okay, so if you're here, if you really magnify, it's not very accurate, but since you don't want to be that, the image doesn't have to be that big. I think this is also a good estimate already, as you can see. How do we remove the labels? We don't want the labels to be on your artwork, so you can just right click and then show label. Be sure your artwork is beautiful and clean when you submit it. So there are artworks last year that are not very clean. So I think it's not very good. Right. So of course you can do the other functions. And for this, for example, how do we do this? This is not a function, right? Because if you draw a vertical line here, you'll intersect 2 points. So that's well known, the vertical line test. Okay. So you can use other tools, like for example, this one. There is this tool called the circumcircular arc for curves like this, for circular curves. So what do? You just click on the 3 points on the arc. So maybe here, here, and here. Okay, and you can adjust the points, of course. And you can hide how do you hide the object that you don't want? So you can right click and then hide. And as you can see, it's here. All the hidden objects are actually here. You can click on them, click on the circle, and then they will also appear again. Okay. And then you can also again change the width to 8. Okay. So in the interest of time, we can just use again the circle here, circumcircular arc here. Of course, we can, for example, this one, you can break this into two functions. So it doesn't violate the vertical line test. Okay. And of course, we are talking about function arc. So hopefully you will use functions whenever possible. Okay, we can use another function here. I already have the equation of the function. So we can just use it because we don't have a lot of time. So the equation here is 0. We can have j of x equals 0.6 sine x times x minus 1.4 plus 8.7. Okay, and then from, I don't know, from negative 1.5 up to 1.1. Okay, and then we can adjust here. I cheated a little bit, not really cheating, because I thought about it. I thought about it ahead, of course. Okay. And of course, for here, we can just use again. Here, you can use actually exponential function, but again, it's up to you to explore it. You can use the functions that you have learned already. Like if you have learned polynomial functions, of course, quadratic is polynomial, cubic is polynomial. And just remove the objects that are not needed on your artwork. And remove also the labels before you submit, okay? And also, please take care of the size of your artwork. Do not submit artwork that you have a small artwork and then you have a very large window. And how do you do that actually? Of course, before you save, you have to resize the window that is appropriate for the size of your artwork. So if your artwork is a bit small, but don't also submit an artwork that is very small. You can just magnify, you can zoom in and zoom out. So before you submit, be sure that your artwork is an appropriate size, and so on and so forth.